Well, good morning. We're going to be able to talk today about business and general aviation, and we have a very distinguished panel to be able to speak these issues. And actually, when you look at the resumes of each one of these individuals, I don't think I've ever had a panel that I've been able to moderate where we've got this much expertise in the different disciplines. You know, our government defines general aviation as everything that's not military or not commercial. So that opens up a broad spectrum. And it's particularly interesting when you have fixed-wing rotorcraft and now you throw in unmanned aerial systems, aerial vehicles, RPAs, whatever we're going to call them, into the mix. And as soon as we start getting those vehicles launched into this sector, they will be part of general aviation. So it's a very interesting discussion that we can have on many various topics. But it's just a privilege for me to be able to be here with you all. GAMA is an association, a trade association of those that make general aviation aircraft, engines, avionics, and down to about third-tier suppliers, along with major MRO facilities, the large ones like Standard Aero, BBA, Duncan Aviation, Jet, and others. And we're an international association, so we have membership from companies all over the planet, and our mission is to promote this industry in Washington, Brussels, Beijing, wherever we need to see general aviation grow. And as you look at GAMA opened up to international membership about 12 years ago, and then opened up to the large MRO facilities that have to work very closely with the original equipment manufacturers about 6 years ago, and then just about 2 years ago we brought the rotorcraft manufacturers on board. So that's still a work in progress. GAMA does not have any specific UAS manufacturers coming on board yet, other than the large companies that deal with that. So what I thought I would do today is, if you could call up the GAMA brief here, and first off, just kind of give you a snapshot of where the industry is from a perspective of looking back over the last couple years, and then looking at where we came since our high water mark back in 2008. Next slide, please. So with me today to be able to cover this spectrum of products, we have Jack Pelton, and I'm going to do a longer introduction of all the panelists here at the end of my little presentation. But Jack is the chairman of the board of AIAA. Mike Hirschberg is the executive director of AHS International. John Langford, chairman and CEO of Aurora Flight Services Corporation. And then Press Henny, just recently retired as a senior VP for programs engineering and testing at Gulfstream, and he's still consulting for Gulfstream at this time. Next slide, please. So let's take a look at where we've been in the last couple of years within the industry. Slide. Yeah, I'll drive here. Okay. So if you look at our spectrum of products and you basically look at weight versus the cost of those products, we span a very large spectrum. And these are certified products, so we don't include those that are in the amateur built or in the light sport arena, although some light sport aircraft are certified overseas in Europe, so they do have a certified certificate on board. So to start with, we'll look at pistons. If you take a look at where we sat between 2011 and 12, fairly flat, but we're seeing some improvement through the first half of the year. Right now, up about 16%, which is fairly significant. And in a normal recovery, this sector is the one that leads. It also is the one that leads in the decline in the marketplace. When we look at our economic models and look at every one of the cycles, the business cycles that we've had in fixed-wing aviation, what has actually brought about a recovery, or what is the bellwether of recovery, is 3 consecutive quarters of plus 3% growth in the U.S. economy in GDP or GNP. And what we're seeing now is, although that has not occurred for 3 consecutive quarters, we're starting to see some signs of change, but it is spotty. Billings in 2012 were down from 2011, so we're hoping that was our low water mark, and indications so far in 13 as far as just the shipment deliveries lends itself to that. Now let's take a look at the turboprop sector. If you look there, the big growth that we saw between 11 and 12 was primarily in ag. And actually, that was really the only growth. It was dramatic between 2011 and 2012 how much the ag manufacturers, and that's primarily Thrush and Air Tractor, were able to grow. And a lot of that has to do with selling overseas. XM Bank financing has been huge for them. If you look now at 2013, through the first half of the year, some significant growth there. What is encouraging in this sector is that it's just not ag. We're seeing growth in other turboprops, even though it's still spotty within the sector, some of the fortunes of some of the OEMs versus others. Billings slightly down between 11 and 12, and that's because some of the larger turboprops weren't selling as well as the smaller ones. Now if you go to jets and take a look, 2012, fairly flat with 11, and 13 we're down slightly. And we have intense softness in the very light jet and the light jet market working up to the mids. And the large cabin long range aircraft still doing very well, but that softness and everything is contributing to the decline in shipments. Between 11 and 12, slight decrease in the amount of billings. So far looking at billings within 13, we're actually, because of the strength of the large cabin long range, they're actually up. If you look at then the total fixed wing shipments between 11 and 12, just up slightly, and that was again because of the turboprop and the ag sector within turboprops. So that's the story for fixed wing. I'm sorry, as well as billings fairly flat between the two. But now let's look at rotorcraft. Totally different story when we look at rotorcraft production. And again, if you look at price matched against weight, we have three different segments that we like to talk about. If you look at pistons, just down the road here in Torrance, you know the big player in that industry is Robinson. And if you look, very healthy growth in that in the piston rotorcraft sector. So 9% growth, especially in this economy, is nothing to sneeze at all. If you look at the single engine turbine with the introduction, again with Robinson and single engine turbine, 34% growth, that's fantastic. That's getting back to some of the growth that we saw in those high water days in a lot of the fixed wing sector back in 07 and beginning of 08. And then as we get into the twin turbines, again, very healthy growth between 11 and 12, so 16%. So a lot of these, what we're finding in this industry is the energy sector is driving a lot of that, but also as these machines become more and more sophisticated and we see their ability speed increase in that, the demand that we see in this sector will just continue to grow. So when you aggregate the shipments and everything for the entire rotorcraft market there, 21.5% growth between 11 and 12. Billings up about 21%. One of the things that we did for our board is we wanted to take a look at what's this market look like. So I'm moving back to fixed wing now, so this just doesn't include the rotorcraft market. But in our high water, or our heyday in recent memory, 2008, look at the distribution in the planet of sales out there. Of course, North America dominated with 62% of the marketplace. Now compare that to what it is in 2012. The world's waking up to the utility of general aviation, and in no small part. There's initiatives going on everywhere. It's just not in China. When you look at what's happening in Indonesia and the Philippines, countries that are thousands and thousands of islands that they have to connect together, this sector is rapidly growing. South America, definitely the market, rotorcraft is very robust there, but even in the Middle East, we've got a lot of initiatives going to try to align the regulatory structure between Saudi Arabia and the UAE to be able to stimulate growth there. And we would have seen more growth in the Middle East if we hadn't had the turmoil that we've seen with the Arab Spring and everything that's going on over there. Now we go to unmanned aerial systems. And we all know that one of those barriers to entry is just getting getting aircraft certified, getting the rules set to be able to introduce those into, especially North American airspace. And it's interesting when you talk to regulators around the planet, they're all waiting to see what we are going to do as far as the introduction of a lot of these machines to be able to say how they're going to set their regulatory framework, although we all know that there's these machines already doing ag work in countries like Japan. But when you look at the size of this market and the predictions that we've looked at, within 10 years, that's a huge market. You look at the number of manufacturers that are already out there, and this is just in the U.S. alone with 232 manufacturers and over 800 platforms. There's an awful lot of them. There are going to be a lot of vehicles in the airspace. And you look at the dominance that the U.S. plays, and this would obviously stand to reason when you look at the military conflicts that we've been involved in for quite a few years here. But this dominance will play out depending on what type of regulatory structures we have here in the U.S. versus other countries. And then another just graphic depiction of what the distribution is for the platforms out there. Notice that we do have, when you look at Russia and China and obviously Europe, they are significant players in that industry. Defense spending, significant, and as the defense activities wind down in Afghanistan, it'll be interesting to see how this distribution goes for unmanned platforms and where we're actually going to move on that spectrum, depending on whether it's going to be smalls or large. And then it's also interesting to look when you take a snapshot of the predictions out there of what happens or how these vehicles are going to be used. And the predictions that we've looked at, and of course Mike can correct this, give us his perspective, I'm sorry, John will give us that perspective. When you look, ag really has a significant role to play in unmanned aerial systems. And when you look at the airspace within the country, and a lot of where we produce crops in this country is in uncontrolled airspace, the problem may be simpler to solve in the ag world than it is in other parts when we want to do surveillance, whether it's realtors or whether we want to deliver pizzas by Domino's, like we heard they're doing in the UK. Those problems may be actually more significant in that part than it actually is to start in that large swath of uncontrolled airspace out there. So now to our panelists. Again, these gentlemen, it's a privilege to have everybody with us today. Jack just came off of the Experimental Aircraft Association annual convention up in Oshkosh. All reports are it was the best ever, best weather ever, and just everyone had a tremendous time up there being able to demonstrate what's out there and what's viable. The manufacturers themselves said that attendance probably about what it was, close to what it was in at least last year, but the actual quality of the sales that were going on up at Oshkosh 2 weeks ago were absolutely phenomenal. Jack cut his teeth for quite a few years at Douglas, and then went over to the VP of Engineering at Dornier. And of course, we all know he ended up at Cessna, first as president and CEO in 2003, and then as chairman in 2005. He's got awards as long as your arm. You see him up there, and I only listed a few of them. But my relationship with Jack started the first day actually before I even came to Gamma, when I was interviewing for the job, and he was, for the first year I was at Gamma for the full year, he was my chairman. And Jack's been called on to serve a lot, being an advisor to not only the Secretary of Transportation, Secretary LaHood, who recently departed, but also serves on the MAC, which is the advisory committee to the FAA administrator. And he is our only general aviation advocate on that committee. Mike was named Executive Director of AHS back in 2011. He basically represents everything that we have to do with vertical lift and the entire community. Publishes a lot of publications that deal with vertical lift, vertical flight being one of them. But has also been involved in the industry for quite a few years, been an advisor both supporting DARPA and the Office of Naval Research on all rotorcraft concepts. Before that, though, worked extensively on the X-32 and the X-35 and working on those vertical lift propulsion solutions for those aircraft. Obviously, again, a very long list of laurels and accolades throughout his entire career, so it's an honor to have Mike with us. John just got back from Alaska. He was flying UAVs up there, and amazingly enough, we're glad to have him today because virtually everybody I know in the unmanned aerial systems industry is back in Washington for the AUVSI convention, and he sits on their advisory committee, so we were able to steal him away. But John is well known within our community. Worked at Lockheed for a while, actually worked on the F-117 when nobody could talk about it, and had a great stint up at MIT working and led this the Dailies project, which was really advanced human-powered flight. And again, his accolades, as long as your arm, been very active in our industry, but playing a key role as we try to figure out what we're going to do with unmanned aerial systems. Finally, Press. Press is very known to this group. Started off working for McDonnell Douglas, was really the brain trust for the C-17 wing out there. C-17 eventually winning the Collier. And when he went in the 90s to Gulfstream, his list of aircraft projects, as we all know, is tremendously extensive. And he retired in March of this year, seeing the 650 come on board, and what a phenomenal platform. And we were talking about flying it the other day, and I still haven't had a chance to get in the front cockpit, but I can't wait. And obviously he's still very active. I mentioned earlier he's a consultant to Gulfstream now, but very active in not only this association, but Embry-Riddle and several others, and awards, again, as long as you can imagine. So what I thought we'd do is just take each one of the panelists, do about a short presentation, and just talk about their different sectors and what they're seeing before we get into some specific questions. And we're going to cover the gamut of everything from technology to regulation and what the future holds. But what I thought I'd do is, as we divide up the fixed wing side, we'd start off with Jack and have Jack cover for us what he's seeing in the piston and turboprop sector. Jack?
Well, good morning, and thank you, Pete. Interesting time to be able to talk about the fixed wing piston aircraft coming off of Oshkosh. So some of you who have not been there, it's an opportunity for many of the innovators, along with the existing OEMs, to put on display the products that they are offering today, and for us as an industry to look at what are some of the forces that they are up against in bringing new products to market and what the overall dynamics of the market are going to be. Let me try to break down some of that. In the piston market, you really have the recreational pilot group, and then you have the individuals who are using the airplanes for pilot training, and I want to hit on those specifically. And then there's also the underlying group who are developing technology that sometimes becomes portable all the way up into the Part 25 world. And what we're seeing is that right now, with the decline in pilot population, the largest demand for the fixed wing piston airplanes are in the flight training market. The bump that we saw, or that we are seeing this year, are airplanes that are really being delivered into flight academies and flight schools at far greater numbers than they are for recreational pilots because of this pilot shortage demand. And I think that's something that really is a concern both domestically and internationally. As the international markets are growing in the commercial world, this need for pilots is becoming more and more of an epidemic that could affect companies like Boeing or Airbus in the out years in not having qualified trained crews available in domestically and internationally. So we're seeing how are you able to satisfy that training requirement and market? And some of the headwinds in those market dynamics are the certification issues. I think probably a lot of you are seeing that in any form of aviation that you're involved in, but the Part 23 certification rules that the light pistons are controlled under have really grown to be rules that also, besides certifying a Cessna 172, are the same rules that you certify a Citation CJ3 to, without any differentiation for the requirements. And GAMA's done a lot of work with the industry and has actually helped to get legislation in place to relook at those certification rules and try to minimize the onerous requirements that you might have that aren't really necessary in the flight training regime. That being said, the international markets is where that flight training requirement is. We've spent a lot of time, as Pete's mentioned, looking at international markets with China certainly being one of the larger potential growth markets for the need for pilots. And the headwind I see, and I'm not trying to talk about gloom and doom, but lay the realities out of what is really dictating where the markets are going to grow and how fast they can grow. Starts with infrastructure. And the infrastructure, when you look internationally compared to what we have domestically, is significantly different landscape. Here, both in the domestic U.S. market, there's over 5,000 public access airports with runways of over 5,000 feet. So there's lots of opportunity to be able to set up a flight school, fly, have good infrastructure as far as trained mechanics, trained CFIs to train pilots, whether you need to have a formal control tower or not, it's all there in place. The fueling, and you go overseas and that's not the case. You're dealing with a new and growing infrastructure that has not really reached down into the light single-engine piston GA environment yet. It's starting with the commercial, you're seeing it in the business aviation, but to see an actual flight school in a remote part of a country that has all of that necessary infrastructure to give good uptime so that students can train and prevail is what's lacking in accelerating the growth. So as an industry, looking at ensuring that the countries understand those infrastructure requirements, building the mechanic and technician population, building the actual fixed base operation is going to be one of the things we'll need to look at to see how the pace of growth for the light fixed wing. But that being said, the need is really there. There's another issue that was highlighted during AirVenture this year is the technology. We've seen some amazing changes in the light fixed wing piston market of everything from now glass panels being common to traffic awareness to all of the other safety features that are necessary, including autopilots that have self-leveling capabilities if you get into a condition where you got low airspeed and high bank angles, to what's probably the next wave of technology that's going to be critically important for growth, not only internationally, but what we're seeing on the horizon with the mandates to get rid of 100 low lead fuel because of the lead content, and that's moving to a form of heavy fuel, whether it be Jet A or diesel. And you're starting to see the engine manufacturers move in that direction because that is a market that then becomes a worldwide market because you can't get 100 low lead in a lot of places. It'll soon be more problematic here domestically than it has been in the past, if not only for the price of fuel, but also for the availability of fuel. So we're seeing that that's the next emerging technology breakthrough that we hope will further the growth in the single engine piston market is engine technology. Because people are sitting on the fence. They're saying big investment especially in a personal plane, if 100 low lead fuel does become obsolete and the replacement fuel isn't adequate for all of the existing engines, should I wait for a diesel powered engine? I had the opportunity to fly a 172 with a Continental company diesel engine in it at Oshkosh and did some flight testing in it, and it is going to help be a game changer from a pilot training perspective. It's very similar to your car. You just push the button and it starts. There's no managing of mixture and prop and other features. Very quiet, vibration levels are low, and only burns 4 gallons an hour. So for the flight training market, you can now take an existing airplane with the range capability and significantly increase the range, reduce the number of fueling cycles you have to have during a training day. So the number of sorties you can have is significantly greater without having the infrastructure of somebody coming to fuel the airplane. And hopefully economically lower the price point of that flight per hour in that airplane. So, we're seeing that technology does change. As technology changes, that it does see the resulting increase in product deliveries associated with new technology. We saw it when the glass panels came in place, which are now commonplace in all new single-engine piston airplanes. And I think we'll see the next bump and surge as the diesel technology starts to become more mature and more prevalent in more of the offerings that are being out there today. And I'm not trying to make shameless plugs for my friends out there at Cessna, but they do have the 182 that has the diesel technology in it that's being offered. And I think that's the kind of the first starting point to see how does that take off and where will it migrate into some of the other product offerings. The other big issue that we've seen over the years that is one that continues to really put a dampening on new entrants into the manufacturing market is the product liability issue. Back in '96, when GARA, which was the General Aviation Reform Act, was passed, it helped limit the tail of liability for a manufacturer. And today you still have many new entrants that are wanting to come into the market, and when they look at the overall cost structure of producing an airplane, and they look at that liability risk and the insurance required, it becomes something that causes a lot of people to take a step back and be reluctant to enter. So I think we're seeing as a result, and I think some of Pete's data indicates that there's more international manufacturers, especially in the light sport arena, who will then grow into Part 23 based certified airplanes in the coming years. This, we believe, will help start to stem the decline in pilot population, but that's a big hurdle that the industry has to overcome. Recreational flying is still recreational flying. The regulatory environment for recreational flying will be one that if there is not any new burdensome requirements such as fees or costs associated with it, it'll probably stay about where it is over time. So we're looking at that regulatory environment, which is something GAMA works very, very hard on, along with EA, to make sure that that lower end is protected. But I think that's, when you look at the single-engine piston market, the training market is the growth segment of it, and it will be both domestically and international, and some of it will be dependent on certification rules and what technologies become available to be able to stimulate that, and then what infrastructure gets put in place internationally. The more interesting market, and when I say more interesting from a growth, from a revenue standpoint and profitability, is really around the turboprop market. And we saw that in the last couple of years. As Pete mentioned, the ag business internationally is doing very, very well. Some of that's being stimulated by the other countries now becoming more resourceful in growing their own crops and being able to take care of their own countries from a domestic product standpoint. And then there's also been the technology help, which is GE, for example, with a new turboprop that they have put out to compete with the PT6 has helped that market. But there's the dynamics of the single-engine turboprop market and the twin-engine turboprop market, which has been interesting. We saw the single-engine jet market, which is still kind of trying to take off, and we saw the very, very light jet market, which was going to be the entry-level jet market, take off kind of, I hate to say stall because that implies that there's an accident at the end of it, but it may have just flattened and stayed where it is. And what I think people have found is that the single-engine turboprop is actually a more viable airplane than the current single-engine jet offerings, and that's because they have better field performance and they have better payload carrying capability. To have that same capability in a single-engine jet would require a thrust requirement that would be prohibitive from a cost standpoint. So you do the trades and you look at whether it be a TBM or a Pilatus or Meridian versus a single-engine jet, and the answer usually comes back, there's more utility features that you benefit with the turboprop. You also have other requirements like maintenance programs and type ratings that don't come into play, so the overall cost of ownership is usually a little better. And because of that, we're seeing new entrants. We have Epic, Kestrel that are coming into the single-engine turboprop market because there is a very, very pent-up demand from a business and recreational need because of the types of performance that those offer. I fly a twin-engine piston, and clearly a single-engine turboprop would be a better solution if the price point was a little bit lower than what it is today for the type of trips that are being made mid-United States to either coast. So that there is some economics that come into play there, and I think there's a kind of a falling out of what's happened in the single-engine jet market and the single-engine or the twin-engine entry-level jet market. I don't know if press is going to go all the way down into the entry-level jets. That has economically shown that maybe the dreams of what that twin-engine entry-level market price point could be were not reality, and that the single-engine turboprops and the twin-engine turboprops are really filling that gap with what the reality is. The twin-engine turboprop market, though, is really occupied by the 800-pound gorilla that's out there today in the King Air, with not a lot of competitive offerings in that area. And people ask, is that going to continue to be a growth market? And based on market share, along with the need, whether it be for military applications, because again, twin-engine turboprops have such a good useful load capability of putting sensors and other products on there, and the medevac, evac, EMS, ability to carry people, a lot more people at a reasonable economic price for 1,000 nautical miles, it's going to be a strong market for a long time, with the opportunity of technology to continue to potentially enhance the growth of that market. We've seen it with, again, glass panel technology that's migrated into the twin-engine turboprops, and at some point in time, there needs to be a change that will happen in the efficiency of the turboprops themselves. GE is doing some work on it, but I think you will eventually see the PT6 get replaced with something that's far more efficient from an SFC standpoint at some point, which will keep that very, very viable as a strong market. So my assessment at the lower end is strong training demand, international growth will support that training demand, and the turboprop products as they're defined have a place that will continue to grow over time.
Well, thanks, Jack, and you set up press very well to transition into the jet world.
Would you go ahead and put up those charts? Good. First of all, I'm going to run through a series of charts here talking about the jet side of general aviation, the business aviation side. And the context I'm going to use here may smack you as being a little bit of a sales pitch. That's not the intent. It's to set up the context for the discussion that really comes at the end. However, if anybody wants to place an order, I think I can probably still help you out with that. The business aviation side of general aviation has been fascinating for me. I was nearly 19 years at Gulfstream after being 25 years at McDonnell Douglas. And so I saw the large transport business and the business jet side of aerospace. And it was a very interesting contrast. There are numerous competitors in the business aviation, in the biz jet arena. We recently lost one in the U.S. with the failure of Hawker Beechcraft, and we're gaining foreign competitors that are growing very healthy, and foreign-owned competitors that are based in the U.S. And so it's an interesting business arena to be working. Here's the Gulfstream product line. It starts from the top, which is our mid-cabin aircraft, the G150, all the way down to the new G650. And so we've got a relatively broad product line. Each of these aircraft, save the 650 at this point, has multiple competitors. And with the introduction of the 650, our competition has launched competitive models for it. They're a ways off yet, but the entire marketplace is very competitive. Now, you'll probably hear in the noon session with the speaker about the market in biz jets being bifurcated. After the economic problems in 2008 and 2009, the small jets, like the G150, have been struggling and are still struggling. And I think that shows up in some of the data that Pete showed you. And so the bottom part of the market is really a challenge. It's challenged not only because the customers for that part of the market probably saw a bigger impact of the recession. It's also challenged because airplanes from the upper part of the market that are resale airplanes or previously owned aircraft are now competitive with the smaller jets in price, and you get a lot more airplane. And so that market has a lot of different pressures on it, and we see that in terms of new aircraft sales of the smaller side of the market, the smaller side of our product line, still being challenged, and that continues today. Now at Gulfstream, last year we put in service 2 new products, the G280 and the 650. The G280 replaced the G200, so that position in our product line wasn't an increase in product offering, it was a replacement. However, the 650, it was an addition to the product line at the top end. It's basically the flagship for Gulfstream now. And I'm going to talk a little bit about each of those aircraft to provide some context of what these airplanes are capable of and what the technology is that's built into those. And that'll lead into some conclusions at the end. So the 2 new products, the 650, a new market segment, the 280, basically the challenge there was to become best in class, and we think we've done that with the 280 on the super mid-size area. Both of them were designed with significant customer input. Both of them, the need for these products came out of our customer advisory board meetings where the customers told us what they wanted. And so the customers, I think, by and large, are pretty satisfied with what we have done to generate new product for them. Both certified and entered in service last year. First of all, the 280. We started with the G200 cross-section and basically changed everything except the cross-section to create the 280. The 200 was short in field performance. The customers let us know that, and that led to new wing, new engine. With the new wing, we were able to get rid of a fuselage fuel tank and provide access from the cabin to the baggage compartment, which is a typical basic requirement that customers like to have on a biz jet. This was the airplane that launched the Rockwell Collins fusion system, so it's got a brand new cockpit avionics suite in it, new tail, and a lot of other neat features in the cabin. You take a look at the cabin, and the cross-section is very similar to the Gulfstream classic aircraft cross-section. We've got a great baggage compartment, much larger baggage compartment in the airplane, very quiet sound levels. You'll see that as I go through this, one of the areas that we have spent an enormous amount of time and resources on is cabin noise levels. That's something that from a business aviation standpoint is a real advantage for the customer. Noise translates into fatigue, and when you can quiet that down, that's a powerful selling advantage. We introduced the Gulfstream cabin management. We've heard throughout the conference about weakness in supply chain. We have wrestled with cabin management systems on previous models and made the decision on these 2 that we were the integrator of cabin systems. We own the Gulfstream cabin management system on the 280 and on the 650 and have forced the supply chain down a level in terms of that system. Introduced HD on both airplanes, and so the visual content is pretty startling in what you can do with the monitors in the airplane. Technology features in the front of the airplane, very similar. We introduced the Fusion cockpit and put features into it that are very similar to what we have with the Honeywell Epic system on the 450 and 550 and 650. The intent here is that the cockpit look and feel is to be very similar across the entire product line. It enhances safety. We've got a lot of features for improved situational awareness. We've got an optional HUD and EVS already certified synthetic vision coming next year. And that points to an area that I think is significant. The the companies that are engaged in business aviation, in business jet design and production, tend to be very agile, and there's a lot of technology that can be introduced quickly in the business aviation arena. EVS is one of those. EVS was first certified by Gulfstream in 2001, and it's now on all but one of our in fact, it's now on all of our models. And so it's one of those things that is a tremendous safety technology. The FAA, I think this week, came out with the draft advisory circular on EVS to land. I can remember doing one of the early flights with EVS on a G4, and the windshield was blocked, but it was obvious with EVS image you're going to be able to land the airplane, and we did that repeatedly in the flight test program. And so business aviation is one of those areas where technology is being developed, is being introduced, that really sets a standard going forward for aviation. That was a plug in case anybody didn't recognize that. The 280 is also environmentally efficient. Some 7 to 12% better fuel efficiency than other aircraft in its class. Quiet, some almost 16 dBs below stage 4 noise regulations, and stage 5 is coming, and the airplane's well within that. Emissions, certainly better than requirements for Cape 6. The airplane's designed to MSG3 requirements, and we have engine trend monitoring on board the 280 as well. Best-in-class performance. We actually produced an airplane that was better than the original spec. We actually increased the range on the airplane 200 miles as a result of the flight testing that was accomplished. So it's 3,600 nautical miles at 0.8 Mach number. And the balanced field length target was 5,000 feet at sea level max takeoff gross weight, and we actually beat that by a couple hundred feet. So the airplane performance is spectacular. Here are range circles out of London. London's sort of the, if you take a look at the globe, is sort of an aviation center of the universe. You see the range circle at 0.84 and at 0.80. You can get a lot of places out of London with the 280 flying at 0.8 Mach number. Set a lot of records. You can see some of them here. Right now the airplane has set over 30 city pair speed records, and so the airplane's doing very well. The production rate's coming up on the airplane, and so it's a great addition to the product line, replacing the G200. Second airplane I want to give you a little context on is the 650. It was it was born out of the customer advisory board. And the customers basically said it needs to be bigger than the 550, it needs to go further than the 550, and whatever you do, it's got to be faster than the 550. And so they were looking for speed, they were looking for range, and they were looking for an increase in Gulfstream cabin size, so we did all that. They also said, by the way, don't you dare get rid of the oval windows that you've had on the classic Gulfstream forever. Those are a real signature for us, and so when we made the bigger cross-section fuselage, we made the windows bigger. So we did what the customer was looking for. It's 14-inch wider fuselage, all new high-speed wing designed for higher Mach numbers, new engines from Rolls, new horizontal tail. The vertical tail was upgraded. The cabin is absolutely spectacular in the airplane. The cockpit is an upgrade to the version of the Epic system, the plane view system on the 550 and on the 450. And it clearly is setting new standards for performance, cabin, and safety. Here's a shot of the cabin. Wonderful cabin. I've traveled on one now a couple times, and it is spectacular. One of the things that we did in the cabin was further reduce the cabin pressure altitude. We were at 6,000 feet at top of cruise on the 450 and 550. At 51,000 feet, we're now below 5,000 foot cabin altitude. We're at 4,800. At the start of cruise at 41,000 feet, we're at 3,000 feet. That is a big deal in terms of passenger physiology, the oxygenation of the blood, the fatigue level at the end of the flight, and so the customers liked what they had on the 450 and 550 and asked us to do better on the 650, so we did. The other thing that we did, I mentioned the sound level of the 280. It's even more impressive in the 650. We are well below 50 dBs SIL with the cabin. We've spent an enormous amount of money. You see the acoustics facility in the middle of the pictures there, looking at every detail in the cabin to make sure that we were making it as quiet as possible. And the Gulfstream cabin management system is included in the 650. It's driven by electronic smart devices. It starts out with a iPad, an iPhone, or an iPod Touch as the basic control. You see an iPhone there. So you can control all of the cabin features with your personal device, and that has proven to be a wonderful addition to the product. In the front end, it's the upgrade. It's Plainview 2. We've got a second generation HUD. We've got second generation EVS. We've got second generation SV, all standard on the airplane. And so it all comes with the airplane at this point, and it's tremendous in terms of situational awareness and flexibility that the flight crew have. Here are some of the benefits for Plainview and all of the features there. I mentioned EVS and HUD. The airplane has automatic emergency descent like the 450 and 550, where if you have a rapid decompression and you have an incapacitated crew, the airplane descends automatically and levels out at 15,000 feet and waits for the crew to revive. It has the three-dimensional weather radar. It has fans capability, WAS capability. You see the EVS and natural vision pictures on the bottom there. You see the synthetic vision picture at the top. Tremendous situational awareness capability, and now we expect to certify all these taking EVS to land as a result of the recent FAA activity on that. It is also very friendly environmentally, some 10 to 17% better in fuel efficiency than previous ultra-long-range business jets, 17 dBs below stage 4. This is actually the quietest airplane in our fleet at this point. And again, emissions well below Cape 6 requirements. It is fully fly-by-wire, quad redundant flight control system. We spent an incredible amount of time with prototype airplanes flying before the 650 to make sure we were ready for it. It is the first completely electrical backup in case of losing both hydraulic systems. It is completely powered electrically for the third source of power. You see the comment there from the FAA test pilot when we went all the way down to no hydraulics. He couldn't tell that he'd lost anything based upon having all surfaces still available with the electric backup power. So pretty successful flight control system development. We have on board the 650 the Gulfstream Advanced Health and Trend Monitoring System. We measure thousands and thousands of parameters real time on the airplane, store them on the airplane, can transmit to ground. If we have an event, it can be interrogated. The communications can go both ways. We have already saved next flight segments based upon what we're seeing happen with the airplane. We have airborne product support where parts, papers, and airplane, and technicians go on an airplane and meet the arriving airplane at a location to make any kind of maintenance issue as transparent to the operator as we can. And this has been tremendous. We've already detected, I'll say, flight crew operations that were not correct as a result of having such a complete system on the airplane. We've detected imminent problems with particular systems on the airplane that the flight crew was not aware of yet. And so this is an area that I think aviation in general will continue to expand and benefit from. A tremendous system on the airplane. Unmatched performance at 7,000 nautical miles at 8.5 Mach number. Our original spec on the airplane was 5,000 nautical miles at 9/10 Mach number. We knew we had a little pad in there. Turns out we can do over 6,000 miles at 9/10 Mach number, and that's how people are actually operating the airplane. It is the fastest certified civilian aircraft in service. The MMO is 925. I recognize Jack is trying to get his Cessna folks to do 935. We'll see what happens when that happens. Cruise altitude 41,000 feet to 51,000 feet, and the target was a 6,000-foot field length for this, and it came in at 58. And so performance of the 650 is actually better than we originally announced as well. Range circles out of New York. You can see where you can get to at 9/10 Mach number. 9/10 Mach number in New York to Beijing, New York to Tokyo. Maybe you have to go 8.9 there. And 8.5, the design max range point. You can see where you can get to out of New York with the airplane. Set a lot of records with the airplane. The first one I'm particularly interested in because I was on that flight from Burbank to Savannah, and we didn't have any particularly favorable winds for that, but we still did that trip in 3.5 hours. Our average speed was 9.1 to 9.2 Mach number for that, and that was great fun. I've got a little closer from that one. In addition to the two products behind that at Gulfstream, and I know we're not unique to this, this kind of activity goes on in other companies as well. There's a lot of R&D that's ongoing to support activities like those two products and other products or potential products that are in the pipeline. We have R&D activities in the flight deck area, vision systems, acoustics, aerodynamics, flight controls, flight simulation, 3D design, cabin systems, cabin design, manufacturing, composites, and supersonics. And I'll just touch on each of those a little bit. In the advanced flight controls, you saw what we ended up doing on the 650. With our demonstration vehicle prior to launching the 650, we had flown fly-by-wire, we had flown fly-by-light, we had flown fly-by-wireless. I still believe that there will be an application at some point in time to move to fly-by-wireless because there's a lot in fly-by-wireless that you can't cut with a rotor burst. And so I think before all the dust settles in aviation, there will be fly-by-wireless applications. A lot in vision systems. We talked about EVS and SV. There's a lot to come in vision systems. I think this is another area that there are a number of breakthroughs yet to come on that. Acoustics, you see a demonstration here. We developed a facility that allows us to test cold on one side of a panel and cabin temperature on the other side of the panel. And if you don't do that, you don't get the right answer on acoustics treatment. And so you see an example there where we measured around our emergency exit windows and found a acoustic leak in the latching mechanism and had to address that to get to the low levels of noise in the cabin. CFD goes without saying, it is an area that continues to expand in terms of the power of the tools and the effect on the design of the aircraft. Significant effort going on with CFD. Both the 280 and the 650 were completely designed with three-dimensional solids. The entire airplane is done with 3D solids, no 2D drawings. Those were made illegal in the design activity, and it took a dictate to change the culture to make 2D drawings go away, but we did it. And so the airplanes are defined completely 3D, and the airplanes go together so well, it's amazing. Rapid prototyping, there's a lot of activity in the rapid prototyping area. Growing parts during the day, growing parts overnight to make sure that you know what you've got, growing parts that you couldn't make any other way. And so this is another area with rapid prototyping, things like 3D printers, laser sinter activity that I think you'll see a lot of expansion in that area. And supersonics. We heard earlier today about the interest in supersonics. Gulfstream is certainly one of those that's interested in supersonics and have been investing our dollars in the development of supersonic technology. I think the business aviation area, the bizjet area, part of the market in aerospace will be the first that will really introduce a supersonic transportation system again. The market is there, the business case is there, and it's a technical issue. It's a technical design problem to get over to actually make the whole supersonic business jet feasible. Now, where's all that leave us? And this is what I really wanted to get to. Our feeling is innovation is flourishing in the business aviation market. The companies are agile. The market is there for technology that really benefits the customer. You see it in the first 4 bullets here. We're setting new standards. We're improving noise and emissions. We're improving the passenger experience with comfort and productivity. And we're improving on safety in the systems, in reliability of the systems, and maintainability of the systems. All of that translates into our customers buy useful technology. And useful technology meaning something that benefits the customer, not a gee whiz thing that we can put on the airplane because we can, but something that is valued by the customer. The key to that is a continuing R&D investment. Gulfstream has benefited greatly from its the leadership in the parent company. The leadership in the parent company was inspired to invest in R&D for the long term, and that's really been the key to the growth of our product line. That is a key item that the leadership has to believe in it and has to spend resources as a result of that. And the pictures there, the 2 new airplanes in service, you have to make the investment, but you want to get the money back. And a development program can't go on forever. And so you have to be able to execute a schedule. You have to be able to get the airplanes in service and start the cash coming back. And so things that affect your development cycle time, if they affect it adversely, they represent real constraints and real burdens. We've seen recent development programs run long. We've seen some in other companies that have gone on an unbelievably long period of time. And that is not a healthy situation. And so the in-service there is meant to say, you've got to get them in service. You've got to launch and finish the development program. And I'll close with my picture from the record flight from Burbank to Savannah. I just love that picture, so I'm going to close with that picture. Thank you.
Well, thank you, Press. So let's switch segments again, and let's go to Rotorcraft. Mike, you know, I showed in the slides what a dynamic place Rotorcraft has been over the last few years. So can you tell us what's going on in that exciting industry?
Absolutely. It is very exciting, and I'm very happy to be here today to be able to talk to you guys. I was struck during this really interesting presentation we just had here about how different our 2 segments are. Fly-by-wire, you know, seen as really, I mean, it's just obvious everything's going to be fly-by-wire. There are no civil fly-by-wire helicopters in the world. In fact, there's only one military fly-by-wire helicopter currently in service, the NATO NH-90 transport, and only the V-22 Osprey is the only other current fly-by-wire rotorcraft in service. There are lots of demonstrators and development aircraft that are fly-by-wire, but none of the other ones are, none of them are in service yet. We're just now getting glass cockpits, so in the military before really Iraq, before Iraq, and there was a change in investments. You know, all helicopters had steam gauges pretty much, and they plowed money into that. So now, I don't know if it's a majority now, but a significant number of helicopters now have glass cockpits, and now a lot of those are being implemented also in the civil world. Press talked about Mach 9.25. You know, we like to fly at Mach 0.0. And CFD, you know, it's so complex. The rotor flows, even in hover, it's, you know, we're getting better, but it's really a challenge to be able to model with much fidelity the airflows for rotor systems, and that's a big challenge for us. We tend to need large wind tunnel facilities like NFAC, so we were very glad that we were able to get that reopened. So a little bit about, I'm going to start these charts a little bit with information about AHS. So we were founded in 1943 as the American Helicopter Society, but we're more than just American, and we're more than just helicopters. As you can see from the chart, we do everything from Joint Strike Fighter, civil helicopters, tilt rotors, UAVs, civil and military. So we cover the gamut. So we're the Vertical Flight Technical Society. We're a lot like AIAA, only focused, with the kind of the important difference that pretty much every country with an aerospace industry has a aerospace professional society. You have A3F for France, Royal Aeronautical Society in the UK, but there are really no other vertical flight technical societies in the world. So we really are AHS International. There are lots of other helicopter societies, associations, must be hundreds probably of societies dealing with the operations and operators and trying to have profitable operations, but we're specifically the technology. Here's this, okay. So, what I'm going to talk about a little bit, a few slides about us, talk about civil market, and then challenges. So, here's a nice, this is without the blades, but this is a CFD simulation of a Eurocopter Dauphin. But a little bit about us, so mentioned Vertical Flight Technical Society, like AIAA, trying to promote technology. We also have a number of initiatives, things like safety and noise. We try to lobby hard for R&D funding for rotorcraft programs. S&T is vital to the future of rotorcraft. We also have a lot of educational programs like AIAA, scholarships, student design challenges. I have a couple slides and things like that. And we, as mentioned, we're focused on military, commercial, and private rotorcraft. Safety for rotorcraft is nowhere near where we'd like it to be. We initiated we started an initiative, the International Helicopter Safety Team, which is now a joint initiative between industry and the FAA to reduce helicopter accidents. It had a 10-year goal to reduce accidents by 80% by 2016, and we have a number of safety management system, SMS recommendations and things like that, and they are getting some traction. Based on what we can tell from flight hours, we look like in those countries that it has implemented the recommendations that there's about a 20–30% reduction, but nowhere near on the track to get the 80% reduction by 2016. So we've decided we're going to, the IHST isn't going to go away after 2016. It's going to continue to work towards the ultimate goal of zero accidents. And for those of you interested in aviation, in rotorcraft safety, you can go to the IHST.org website. And this is modeled a bit after CAST, but that was airlines, and most operators have fewer than 5 helicopters. Most are private and individuals with one or companies with up to 5 rotorcraft. So it's human factors is the leading cause of accidents, and this is actually both military and civil. About 80% of accidents are due to human factors. Noise is another important initiative that we've just kicked off. We're trying to get the manufacturers and the operators and the public to reduce helicopter noise generated, noise received, and noise perceived, so people stop complaining about helicopter noise. There's been some legislative, regulations or restrictions, flight restrictions, New York and also in LA and Las Vegas that restrict helicopter flight paths based on noise. And it's it's not just the average or peak noise, it's the fact that it's impulsive noise. So the fact that it's a wop, 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 wop is really annoying to people. And so we're looking at the psychoacoustic effects of that and what we can do to prevent it both from the actual, on the actual aircraft and its operations. And, you know, if there's more public relations, public education on the benefits that, that vertical flight brings to society. Okay. So we also have an annual student design competition like AIAA does, and this year, as we just announced it on Tuesday, yesterday, is basically taking the DARPA X-plane program, VTOL X-plane program, which we've called XVTOL, so it's roughly equivalent to the DARPA program. But it's basically asking students, and we get competitors from around the world, lots of really ingenious designs from students, like I said, all over the world. And so this is a DARPA picture here, but it's looking at high-speed 300-knot VTOL aircraft and with good L over D. So something we're really interested in is trying to expand increase innovation and expand the art of the possible. So this is a video. Can you see if you can get this to play? I hope it's on there. Maybe it won't play. I forgot to check this out beforehand. So maybe the video won't play, but it doesn't play if you click it. So one of our, okay. Not very interesting here. Okay, just go back to the picture. So one of our projects, we had a challenge. Let's see if you can get the picture to come up. We had a challenge for the a human-powered helicopter. And this we started in 1980, and we had no idea that it was going to take 33 years, a third of a century, for somebody to accomplish this. We made the cover of Aviation Week, and it was quite a spectacular feat. Please go to our website, vtol.org, and watch the video. So the requirements were to be able to get a helicopter, no, I should say it. The requirements were to get a contraption off the ground for 60 seconds, to have the lowest part on the aircraft to be at least 3 meters, so almost 10 feet, and to be able to stay within a controlled box of 10 meters by 10 meters. Do an auto, boy, my slides are all messed up now. And so we had this challenge, and over the last, so we started originally with a $25,000 prize, and then it went to, after 15 years, we had a couple successes where 2 aircraft had gotten off the ground by, measured in inches and seconds. And we were able to get Sikorsky Aircraft to have a 10-fold increase to $250,000 in the prize money. And so we saw an explosion of interest in students and young innovators taking on this challenge. And even a few weeks before they actually did the prize-winning flight on June 13th, there were still, well-respected experts who said that if it's not theoretically impossible, it was practically impossible because you could never get everything perfect for that flight. So we like that. We like having an impossible challenge that inspire and innovate, inspire innovation from students. And so now that we've won after, now that we've had a winner after a third of a century, we're looking at other challenges too, and I think that was brought up during Administrator Bolden's discussion, and we think that's really an exciting way to drive innovation in aerospace. Okay, let's try the next slide, and let's see what I did here. Okay, so just kind of a lay of the land. The largest market for both commercial and, or I should say civil and military rotorcraft is still North America. It's really the U.S. Is the largest purchaser of both military and civil helicopters. These are I've listed out the major rotorcraft manufacturers for the major the regions of the world. Bell, Boeing, and Sikorsky are the three big ones. I've marked with asterisks the companies that only make military helicopters. And I've based this based on where the headquarters of the company is. So I don't have one here, AgustaWestland and American Eurocopter, which both produce a lot of helicopters in the U.S. But basically, you know, the U.S. and Europe have the majority of the helicopter market in the world. But in Asia, there are a lot of companies now that have developed their indigenous capabilities. And these were often started as, okay, they're going to do licensed production, or in China's case, unlicensed production of Western designs. And that really grew their expertise and capabilities, and now they are developing their own aircraft for civilian and military use. And interestingly, the bottom right there, the HAL Druve advanced light helicopter has actually been exported out to different countries because India has high mountains. It's very difficult to get helicopters to perform in high mountains. So several countries that have high mountains have also bought the Druve helicopter. So that's, I think, one of the few cases of, I think that's the only case of India exporting aerospace products to other countries, and I don't know, maybe other, I don't know how many sales they've had in biz jets or fixed wing aircraft, but it's in Asia. But it's, anyway, an interesting data point. Okay, talk about the forecast. So mentioned North America is the largest civil market in the world, but there is pretty much slow growth projected over the next 8 years or so. So the U.S. military has been the world's largest customer, but we're winding down 2 wars, and we have sequestration and these other, even if sequestration were removed, we still have enormous economic challenges, both for the government and for the civilian economy. So, huge, I think it's supposed to be $1 trillion cut in defense over the next 10 years. So, significant reduction in purchases expected. Now, interestingly, in the budget submittal, the FY14 budget submittal, it wasn't too traumatic of cuts, but there were cuts. So, Rotorcraft, I think, played the largest role in the 2 wars. They were the key enablers for being able to prosecute those wars. But we're expecting now to see a roll-off in orders, obviously. Now, we see also significant growth in the offshore oil sector and some new model helicopters, some larger helicopters being developed to reach those farther offshore platforms. There is also significant market growth in Asia Pacific as well as Latin America, but they're relatively small markets today. So even though they're high growth rates, the actual size is fairly small. There's a huge economic potential in China. They formed China AOPA. They're trying to develop the infrastructure, training, knowledge, experience with civil aircraft, rotorcraft specifically. But both India and China are huge potentials, but they have regulatory inhibitors. China, I think, has a plan for changing regulations. I think since they're not a democracy, it's easy for them to change regulations. India has perfected the democracy in all of its bureaucratic encumbrances, and really don't have the skills and expertise to regulate helicopters. So they regulate them like civil fixed-wing aircraft. They make them taxi down the runway, and they have all kinds of ridiculous requirements that don't allow them to be operated like helicopters should be. And then I mentioned there have indigenous development of other Asian countries. So here's the forecast. This is civil and military combined, and I'll tell you the next couple of slides. Basically, civil is going up and military is going down. Overall, $250 billion over the next 10 years, 25,000 rotorcraft. As mentioned, there is growth, and unfortunately I don't have this broken down by geographic region, but North America still remains, is predicted to be still the largest civil market for the next 10 years. And I said that last one there. Okay, so here's civil. So about 20,000 civil rotorcraft, 5,600 piston powered. So these are much smaller and cheaper than aircraft with turbines. All those light turbines are now really starting to take off, literally. So of the $250 billion of sales expected in the next 10 years, about $88 billion of that is civil. There was a steep decline in helicopter sales over 2009 and 2010. It has turned around. 2008, I think, was our peak year where we had 2,000 civil helicopters were built. This is expected to be surpassed again in 2017. So when Pete showed the rotorcraft industry booming, it's not as good as it was, before the economic collapse, but it is, business is booming. And then the projection is to continue to rise to about 2019, and then we see a cyclical downturn because they've replaced a lot of helicopters, and so now they have good helicopters for another 20 years or so. Military, as I mentioned, is forecast to be down, but it's a huge market, about almost twice the size of civil as far as value, and what does that come out to be? About a third the size as far as numbers. And this reflects declining number of purchases by US and European defense industry. And with this reduction in military production, the military has historically been the largest funder of rotorcraft R&D and science and technology. And with the reduction in production, this is now, the DoD funding has been about, total with all services, has been about $100 million a year for rotorcraft, which is really kind of a pittance compared to the huge amount that's gone into other sectors. So it's always been low. We don't see it going up, and then NASA has cut its civil rotorcraft investment as well. So that's, I guess, the thing from a technology organization. That's what concerns us the most. So here's some charts here on market share. This is units. So you can see Robinson helicopter here has over a quarter of the world's production. At one point, they were actually producing close to 1,000 aircraft a year. Maybe about half that now, but here in Torrance. So they have a two-seat model, the R-22, which was the best-selling helicopter in the world. They came out with a four-seater R-44, which then became the best-selling helicopter in the world. And they've now, in the last couple of years, come out with the R-66, which is a five-seater with a turbine. And that's really taken off as far as sales. And because of that, there's a number of other companies, including Bell Helicopter, announced a small single-engine turbine that they're going to try and compete with Robinson. And a number of other companies also either already do produce small piston or turbine helicopters or are planning to come out with models in that low end. Eurocopter, you can see here as far as unit value is 22% there. The Russian helicopters conglomerate next, and we see AgustaWestland, there we go, and then Sikorsky over there, and Bell. Okay, and then the whole rest of the world as far as units. As far as dollar value for market share, and this is new production only, so there's a lot of remanufacturing and refurbishment of military helicopters, but this is only new production. So Robinson then fades to a tiny little 1.5% somewhere over here. Where is that? Okay, it's right there, 1.5%. Based on value, because they make a lot of really cheap helicopters, really inexpensive helicopters. And then Sikorsky is the largest one. Eurocopter, Russian helicopters, AgustaWestland, and Bell, and then Bell, Boeing, and then Boeing. Okay, so there's much different distribution when you look at it versus value. Okay, so just some summary of some of the challenges I may have alluded to or maybe not, but safety. So there's a public perception, and this interacts with the public perception about noise. People see a helicopter, and they, even if they can't hear it over the the Manhattan downtown traffic noise, they still think it's annoying because it's helicopters make noise, and it's an impulsive noise, and maybe they're afraid of it falling on their heads as well. So, the accident rate, I think, is something generally around an accident a day. So, 300 to 400 accidents a year, which is much less. The accident rate is much higher than we would like. We'd like to tell the public that helicopters are safe, so there's fine statistics, everything like that, but it's certainly not at the airline level of safety, and obviously zero accidents should be everyone's goal. Noise, people move next to hospitals and then complain about the medevac noise. Helicopters provide a vital role in society, both for emergency medical services, fire, police, search and rescue. So lots of vital roles, but people don't like the noise. Mentioned government investment. The U.S. investment has been very minimal, I think, peanuts in both military, both DoD and NASA, whereas in contrast, Europe has invested significant amounts of money in developing rotorcraft technology, and Eurocopter and AgustaWestland have some very incredibly capable helicopters as a result. And I think it's something about 2 or 3 times what NASA used to invest in rotorcraft. Asia is now investing heavily. It's a good market, as you saw, it's an expanding market. Europe wants to expand its piece, and Asia wants to get a piece of that. We talked a little bit. I think it was maybe Jim Albaugh about design, capability of design in the U.S. and elsewhere. I mean, it used to be World War II, Korea, Vietnam era that you'd be designing aircraft. You'd come out with a number of new military and civil models every year. Well, as far as military. There hasn't been a clean sheet helicopter design that's reached the U.S. military service since the Apache in 1982. So basically the Apache and the Black Hawk were designed during Vietnam. They had their first flights at the end of Vietnam. So, I've had some fits and starts, things have been canceled, but it's basically everything has been the latest model of the Apache, which is really good, or the latest model of the Black Hawk, which is really good. Really incredible updates of really old designs. So we would like to see clean sheet helicopter VTOL designs to be fielded, and there's technology development work, the Joint Multi-Role, which is sort of like the Joint Strike Fighter development of the 1990s. So it's a technology development program now. We'd like to see that reach an acquisition program. And then another thing is, so the design teams have atrophied, and this is on both the government and the industry sides, and you see a lot more teaming. There are a lot fewer dollars, so companies are teaming more. And internationally, there's a lot more joint ventures and stuff. Okay, so innovation, because of everything I've described here, there's few opportunities for really revolutionary improvements. The V-22, there was a tilt rotor that first flew in the 1950s, so it took over 50 years to get a tilt rotor fielded. So the tilt rotor, so this was a clean sheet design, but it was not a helicopter. So VTOL aircraft became operational in 2007. There are a lot of great ideas out there, some eye-watering concepts for vertical flight that need to be explored and developed and investigated, but they have to be funded. So there's some talk about challenges earlier. Can a challenge, we talked about the human-powered helicopter challenge. That had some tremendous technology and innovation breakthroughs. There was the green aircraft challenge that had some tremendous breakthroughs. Maybe there can be a electric helicopter, extremely short takeoff and landing aircraft that would be an autonomous capability to take people around as an electric air taxi. Let's see some demonstrations in this respect. And so I have that there in my last slide. I was jumping ahead. So why not have an autonomous electric pilotless air taxi rotorcraft? Let's set a challenge that maybe academia can look at this, industry, and see what kind of exciting concepts can come out of that. So this is a summary of everything I've said, and I'll be looking forward to answering questions and talking more about this in the Q&A section. So thank you.
Thanks, Mike. Well, now on to something that's exciting for me, obviously, because unmanned aerial systems are going to come into our world in general aviation in the not-too-distant future. We're already seeing them with a lot of law enforcement agencies, with the COAs that the FAA has been giving. Last week, we saw that Boeing certified 2 actually commercial UAVs on the large category. So this is coming. We know that some have classified it as a tidal wave, but that tidal wave will be modulated a lot by our regulators. So John, tell us about this sector.
Okay, well, thank you. Before I do that, I want to just do a couple of audience surveys here. So how many people in this room are currently licensed pilots? Okay. And how many people in the room would like to be able to fly themselves but aren't currently licensed pilots? Okay. How many people in the room own an airplane? And how many of you have thought at some point that you would like to have a flying vehicle, an airplane? Okay. And the last question is, how many of you have flown on a Gulfstream more than twice in the last 3 years? Okay, very good. So what I wanted to talk about is not how UAVs are going to be used in agriculture, but really what, for an outsider's perspective, you're probably wondering how a UAV person is on this panel. I'm wondering the same, or have been wondering the same thing. But what I thought I would talk about is what we in the industry see as a convergence between manned and unmanned aviation, and how these things really are not opposite ends of the spectrum, but are very, very closely related and will be more so in the future. So there are some very real unmanned airplane markets, right? ISR, science, and I think the small UAV market and first responders, those are big. The chart in here is the U.S. utilization of unmanned aircraft flight hours per year. It's gone exponential since 9/11. It probably will drop. Most of that is military UAS. Like many technologies in aviation, this has been matured and developed in the military and will be transitioned into civil applications. Unlike some of the technologies of the past, I for one don't think it will be a direct we're going to bring the Shadows and the Predators back from downrange, and we're going to start flying them in the national airspace. And I know that that's not a universally shared view. We're going to talk about it more at length this afternoon in another panel. But I think you're actually going to be moving technologies more than the current actual airframes yourself. What UAVs have got to do is really drive a safety revolution both in the unmanned side and in the manned side. So you have to kind of move to the next stage of what we consider a real revolution, and that top curve, an exponential growth curve like that, everybody envies that. Okay, that's what we're all looking for. Every business plan has that sort of hockey stick growth. Very few actually achieve them. Obviously, the way that UAVs have been used so far is data collection and relay. That's primarily what they've been used for to date. Then they began to be used for air-to-ground weapons delivery, and as Mike was talking about, you got to use the word impossible or never going to happen very carefully in aviation. A lot of people a few years ago said, never going to have a robot launching weapons. Okay, well, that's in the rearview mirror. We do it all the time. It's actually become one of the image problems for our industry, and we'll be talking about this afternoon. We're now moving into cargo delivery, just getting started with that. It has been done downrange in Afghanistan. It's going to be more and more used. Air-to-air is sort of the next big thing that's happening, both in sort of refueling and eventually in unmanned combat air-to-air operations. The day that an unmanned fighter takes down a manned fighter will be one of those milestones in aviation, much the same way when a air-to-ship missile took out a destroyer for the first time. And then finally, where we'll get to is people, carrying people on board robotic airplanes, okay? And again, you go, that'll never happen. Well, you know, the administrator talked about that some this morning. The place it's going to start is casualty extraction, critically wounded, sort of medevac type of applications. That'll move once that's been proven reliable. That'll move to special missions, and eventually it'll move to general aviation. And since Charlie brought it up this morning, you know, I just have to mention the Jetsons went on the air in September of 1962. So we passed the 50th anniversary of the Jetsons last year. And NASA may not say that that's what they're in the business to do, but Aurora is in the business to do that kind of stuff, which is to make aviation much more commonplace. Because when we kind of talk about the issues on this panel, we're essentially dealing with markets that are flat. And I'm going to show some charts here and to sort of explore why. This first chart, though, is just kind of looking at to sort of make the case, there's no reason that aviation in the low end, in the area we're talking about in this panel today, should be a flat market. The worldwide demand for higher speed transportation continues to grow. The growth in the big jet transports obviously tracks GDP, but the growth in the general aviation sector has not. This is a chart that sort of plots GDP versus general aviation operations, and you can kind of see the blue line is the steady increase in U.S. GDP, and the red line is the number of general aviation operations, and we are today roughly where we were in the 70s, okay? And there's ups and downs driven by different things, but it certainly is a case where general aviation flying has not matched the growth in GDP that other parts of flying has. And there's fewer pilots. I mean, we talked about the main market for small aircraft today is actually in pilot training markets. A lot of that, of course, is international, and a lot of that is to provide the pilots that are needed to fly the big Boeings and Airbuses, where there has been good growth in that and where that growth has tracked GDP. But the number of pilot licenses issued in the United States has shown a continuous decline. So why is that? Well, I think it's because of safety and money and the complication involved. When you talk to people in the general aviation business, I was talking recently with a guy who'd been the CEO at Cirrus, and you know, when they're trying to sell an airplane, the first three things that the people are interested in are number one, is this thing safe to fly on? Am I going to die if I fly on this airplane? Second thing is this something I could fly myself? Am I going to die if I try to take the controls and fly the airplane? And the third question is this something that's safe to take my family on? Am I going to kill my family? Are they going to die if we do this? And so safety, safety, and safety is absolutely critical throughout this. And of course, in aviation, we've developed a culture that is focused on that, and yet in this market segment, it is still far and away. Now, the cost and complexity beyond that, to be safe, to operate safely, results, it can be done, and this industry demonstrates it, but it's done with a lot of cost and complexity. It costs a lot of money, takes a lot of time to be current in today's air traffic control environment. And as everybody knows who's done this, most of learning of being licensed is not the stick and rudder skills. It's the integration, it's the work with the air traffic control system. Modern general aviation airplanes, and there has been a lot of advances in these, have really exploited the advances in composites, aerodynamics, propulsion, glass cockpits. They're beautiful airplanes. And yet, when you look at the safety record today and the safety record of the older airplanes, they are not fundamentally different, okay? And I would posit that they are not going to lead to a change in the trends that we saw earlier, trends of fewer pilots and fewer general aviation operations, despite, in the last 10 years, some real changes in the way these airplanes are built and the way they look on the outside and on the inside. My hypothesis and the sort of the thing I would bring into this meeting is sort of throw out the idea for discussion that reversing the decline in general aviation is really only going to come from incorporating the technologies that are currently coming out of what we call unmanned aviation, unmanned airplanes. Now, I believe that's a misnomer because I don't think it's really as polarizing as we make it out to be of manned versus unmanned, but it's really where you fall on this spectrum of autonomy or of automation from systems that have essentially no automation on board and depend entirely 100% on the human pilot to systems that are fully automated and where the human has only a supervisory role in the operation. The technology on that is being driven in this unmanned space, and that is what I think this convergence really comes out of. Now, it comes. I'm sorry that I think Jay-Wan has left the room, but one of the big beneficiaries to driving this revolution is a series of NASA programs over the last 15 to 20 years in the systems integration area. Tom, what do you call this in your portfolio? The systems integrated systems portfolio. And I'd like to call out five of them that I think have had real influence. The first was the Agate Alliance. The second was the General Aviation Propulsion Program, the GAP program that was doing, helped drive small engines in this area. ERAST, which was a program that did unmanned aircraft development, had 4 different companies in a consortium. I just tossed out that when NASA started the ERAST program in 94, and it actually started in like 92, the 4 companies that were in that, the 4 small businesses together, had combined annual revenues of about $25 million. This year, all 4 of those companies still exist, and they have combined revenues of about $2 billion. And so when you look at what the government can do, it's not just the technology that is driven in this, but it is, sort of an industrial policy area too that helps drive the whole system forward. The SATS program, the Small Aircraft Transportation Program, that was focused not just on the airplanes, but on the airspace, that just as you can have unmanned aircraft or reduced human intervention in the airplane side, the same is true on the ground side. Unmanned towers, highly automated airport operations that allow you to expand the number of towered airports, effectively towered airports. And finally, the current program, which is the UAS and the NAS program, which is working technologies directly aimed at integrating UAVs into the national airspace. Now, some of these are just beginning to have impact, even though the program was done a decade or more ago, and I think that's a characteristic of research. And some of them, the relevance of the program is much more clear even today than I think it was when the program was conducted. SATS, for example, I think is directly relevant to some of the things that we see of the decline of the number of airports that are served by commercial service. That number of airports has continued to go down. The NASA SATS program was aimed at reversing that trend. There have been a number of experiments conducted, some as experiments and some just sort of became experiments. Dayjet is one that we've studied with, and I would say with Bruce Holmes. Several of these charts here have come from Bruce. But Dayjet was an experiment at serving the low traffic density routes. Essentially an on-demand air transportation system, essentially what we sometimes call air taxi operations. They had set up in Florida. They ran a number of, I think it was, the numbers are there, 28 airplanes, 61 of these day ports, and you could access 375 cities, which is, Dayjet was serving about the same number of cities as currently are provided in all of the United States by the majors in terms of commercial service. Now, Dayjet did not make it, okay? They went under in 2008, and the people who have sort of studied, okay, what happened there? It's obviously economics, technology, and their interaction together, but one of the things that comes out of that is the ratio of the pilots to airplanes, if you look at the big majors, they employ something like 19 pilots for every airplane that is on the roster. Dayjet was operating down at I don't know if it's on this chart, but it's like 4.5 to 5 pilots on the payroll per airplane. And you didn't have to get to zero. You don't have to get to zero on this to cross that threshold of economic viability, even on the model they were operating. But you need to get down, it's been hypothesized, to around 2, okay? Now, that is directly where what we call unmanned airplane technology comes right in, because the first thing you want to do is drive from 2 pilots in the cockpit to 1, a single pilot operations, with essentially what amounts to think of it as a robotic co-pilot. Now, it may have anthropomorphic dimensions, it may not, but it is essentially automating enough to where you can have single pilot operations. And particularly on areas where there's no passengers on board, we think that the number of, that it's quite practical to move airplanes around in the system, to reposition airplanes with nobody on them. This is, I've been mentioning a couple of times, the number of commercial airports served in the U.S. has been going down. That's just that statistic there. So as you look at the sort of on-demand air carrier service, which as a UAV person I actually think is going to be one of, when we talk about integrating unmanned airplanes or robotic airplanes in the national airspace, I think this is one of the kinds of things that it's really going to happen. It's not going to be a lot of predators flying around in the kind of model that people have become used to downrange. It's going to be stuff like this, where you have a mixture of the airplane. There's going to be real-time logistics. The health monitoring that Press was talking about is exactly the kind of thing that you're moving a lot of data back and forth between the airplane and the ground. That means the people on the ground have a lot of knowledge about what's happening on the plane, what the trends are, and what may be about to happen. Tying the airplanes together. You're not just going to take the people out and depend entirely on onboard automation. You're going to have connectivity. And that's going to be the networks in that. And then the optionally piloted airplane and its interface with NextGen. The part that our company has focused on is this optionally piloted aircraft. It started as a venture where we kind of looked at the FAA regulation and we said, I think it might take longer rather than shorter to have the FAA be able to fully accommodate the regulatory changes that need to come about to operate UAVs in the NAS, and so we started work on an OPA that could be flown manned when it needed to be, and fully certified, normal category certifications, and operated in the NAS. Could be flown as a robotic airplane, unmanned, when that was appropriate in the appropriate airspace operations. And then there's a hybrid mode. What the airplane has actually turned out to be used for a lot is a hybrid mode where it is flown remotely like a UAV, but it has people on board who are doing either are researchers, are what we've come to call the only FAA-approved see and avoid collision avoidance sensor on board, is the person, and eventually as passengers. Now, our particular thing, we started with an existing general aviation airplane. This is the Diamond DA-42 in its MPP version, the ISR version that they make. And it has fitted into it a complete UAV, triple redundant flight control system that we have developed on our other robotic airplanes. And in this initial instantiation, they are very parallel systems. That was done both for cost and for certification, and certification really translates to cost, because we wanted to preserve the EASA and FAA tickets, certifications that came with this airplane as you buy it, so that it could be operated in the NAS. And then when you switch it to a UAV, it is not an FAA ticketed aircraft. It's operating under the way UAVs do under a special airworthiness certificate or in controlled airspace. So how does it fly? I mean, one of the pictures that people have of UAVs is of remote cockpits, that there's somebody sitting on the ground with a stick and rudder and a bunch of instruments, and if they lose the radio data link between them, the airplane goes out of control. Well, that is really not how it's done on most UAVs today. There are UAVs that have been done that way, and there are a number historically, but that is not the way that most modern UAVs are done, and certainly not the way that most of them will be done in the future. The Centaurs works off the NATO standard, which is called STANAG 4586, and it's basically a data interchange protocol that allows any ground station to talk to any airplane that complies with this standard. And in that, and I know it's a little hard to see in this, the level of command that the human has over the airplane is much closer to what an air traffic controller has over a flight that he or she is controlling than what you think of as a remote cockpit. You can tell them to turn left, you can tell them to climb, you can give them assigned altitudes, trajectories, you can give a fully prescribed waypoint that either just follows GPS points or follows the standard air navigation data points, and it follows that. You can take control, but when you have control, you can give limited, they call it knobs mode, where you can have direction, altitude, and airspeed. And then you have modes like takeoff and land, and when you tell it to take off, the airplane does everything below that in the system, and it's quite it's very interesting when you do this in a UAV ground station on the ground, and it's something entirely different when you're sitting in the cockpit, and the ground station, by the way, can be in the cockpit as well as on the ground. And so the level at which you're interfacing with this airplane is moved several levels up from the sort of the experience today of sitting even in a glass cockpit. The idea of how this airplane is supposed to work is that you could self-deploy. You could take off with a ground station in the back seat, fly through controlled airspace out into a downrange mission, convert it to a UAV in a matter of the spec was 4 hours or less, fly it as a UAV. When you're done, convert it back into demand, fly it back into controlled airspace. But where we really see this all going as it plays out is sort of 3 levels. Where we are today as an airplane, it's based on an existing general aviation platform. There's 3 basic markets we see for that. One is ISR, like most UAVs are used for. The second is scientific research, and I think it was mentioned in the, we have one of these on the North Slope of Alaska today, supporting a CO2 and methane measuring instrument. And airspace R&D, and one of the launch customers is the Swiss government, the Swiss Air Force actually, has purchased one of these airplanes and is operating in Switzerland to do research on collision avoidance systems and how you integrate manned and unmanned airplanes in the same thing. It's certified in the manned mode, and it operates pretty much like a dedicated ground control system. Now, the next step, though, to this is something that would be, the problem with that market, by the way, is that it's small, right? It's the market is, if we sell a few dozens of these airplanes, we'll be very happy with that. Tens to hundreds, 10 to the 1 to 10 to the 2 is kind of the market on that. The next step is to move into things like cargo delivery and air taxi, and that's interesting because the market numbers are much larger. We say a few hundred to maybe in the thousands in that. To do that, you have to get this thing certified for single pilot operations with passengers on board, and you have to get it certified for UAV flight in the NAS without passengers. That's why things like the NASA program are so important. You also move in that from a model of today's ground station model into more of a fleet dispatch center. You don't actually have the controllers. The controllers could, in theory, control these airplanes directly. That is just such a radical departure from the paradigm that we're not proposing that. But there will be a sort of shadow air traffic control system, more akin to the fleet, the dispatch centers that the airlines use today. And those guys will be controlling the airplanes, okay? That's who's going to have control of the airplane. And that can become a commercial service, too, not just for big commercial operators, although we see commercial operators being the next step. And then eventually, and I've put sort of 7 to 10 years, it's probably more than that, but you move into that personal transportation market, which I think is where you really begin to change the paradigm of what today we call general aviation. The market there is large, right? Thousands to tens of thousands, maybe hundreds of thousands eventually in this, with an airplane that is essentially certified. You have to get it certified for UAV flight in the NAS with passengers. And that is a big step, but that is an important step, and it's a very possible and very doable step. Now, again, those airplanes are not out operating by their own. There's a centralized network operations center involved in that, and obviously there's a lot I've kind of skipped over to fit this into a short presentation, but to me, that vision and that technology is why it makes sense to include unmanned aircraft in a panel discussion such as this, because I happen to think that the UAV community is not the threat to the general aviation community that it has sometimes in the past been sort of portrayed as, but is actually part of the solution, maybe go so far as to say the salvation of the general aviation industry, which has, despite a lot of other advances, not really been experiencing the kind of growth that I think we all want and expect to see in that business. So those were my comments.
Well, thank you very much, John. There's a million places we could go with questions, but what I thought I'd start with is just looking at the economics, the global economics of each one of the different sectors. And Jack, I'll start with you. When you look at Cirrus, Continental owned by the Chinese, Piper owned by the Sultan of Brunei, a lot of investments happening from different quarters, and just the situation that John just explained with the decreasing number of aircraft that we're pumping out the door in the piston and turboprop sectors, where's the investment dollars coming from?
As far as our investment dollars currently in the existing companies, or the influx that we're seeing, I think the problem has been with the existing, I'll call it legacy companies, OEMs, is that nobody has made any reasonable profits in the single-engine piston markets. Matter of fact, most have lost money or actually gone underwater. And that, in our publicly traded companies, just is not a business model that makes any sense. Why is that so? A lot of it has been the overhang of the liability issues. A lot of it is that we have cost models that today are not breakthrough. When you look at a Cessna 172 or 182, and you're talking the majority of the cost of it is in engine and avionics. There's the labor cost of it's only about 12 to 13% of the total airplane. The price points keep going higher and higher, so we have to find some sort of manufacturing breakthrough to drop the overall cost so that somebody will want to step up and spend the money to develop those types of products and have them be profitable. Bring the types of margins that current investors in a public company are wanting. that's kind of the historical where we are and why you aren't seeing the investments being made. When you look at the movement of these international companies, they are taking an investment strategy that says I can leapfrog and buy technology and I can become at year 15 or year 20 on the development cycle instantly by buying Continental, buying Cirrus, buying some of those companies. And we have enough, and I'm saying we being those folks who are doing it, there's enough growth in those areas that they believe with some incremental investments on some pretty good products already, they can get to a point of profitability and satisfying the market needs in their country. So it's a little different approach. I mean, it's a Wall Street versus am I building infrastructure and capability and future internationally that's not the lens we look through today.
Press, when we go to jets, we've got the largest plant that Dassault has. They employ more people down in Little Rock than they actually do back in Bordeaux. You've got Embraer that's built a facility in Melbourne. You've got Honda Jet. The only place they're going to produce is in North Carolina. What is the investment dynamics in the jet world that you're seeing?
Well, I think in each of those cases, it's a recognition that the jet market is still dominated in North America, even though we've seen tremendous growth in China. And there is an advantage to be there. There is an advantage if you're a foreign subsidized entity to be there. And so there are a number of levers that the foreign manufacturer can pull to give them an advantage in competing with you.
So if we look then, Mike, at Rotorcraft, as you mentioned in your chart, if you take away the military and you really look at dominance in the civil market, you're looking at Augusta-Westland and Eurocopter. And if you look at Bell, one of our major U.S. manufacturers, they're producing actually their civil fleet north of the U.S. border up in Canada. So as you look at investment dollars flowing into what we see as a growth market right now, what's happening in the rotorcraft sector?
Sure. So pistons are, really taking off, and small turbines. One of the small piston helicopter manufacturers, Enstrom, was recently purchased by a Chinese investment company, and that's really good for them, and I think for the light helicopter market, because this has been a brand they hadn't had any new products for, I think, 30 years or something. So, and very, very relatively low number of sales. So I think that's good for the light market. There's some good, healthy competition there now. The big companies can't make any money at the low end. Bell, as I said, they've been out of the light market when they stopped making their 206, the Jet Rangers. So now they're getting back into it, basically looking at the success of the Robinson R66. For the larger manufacturers, I'm not sure if it's still true the last couple of years, but I know for a long time Eurocopter sold more civil turbine helicopters in the U.S. and all the U.S. manufacturers combined. So, it's a big market. Eurocopter's been very successful in it. Augusta-Westland has some really fine machines. And I don't mean to knock the U.S. manufacturers. Sikorsky and Bell, they have excellent products as well. But we really see a lot of products and investment from the European companies and from the European Union in technologies. Does that answer your question?
Absolutely. And John, as we look at the unmanned sector, if you look at the defense dollars that have gone into this sector to really launch it in a massive way, and now as we see those defense budgets declining and those inventories out there, and a need to have to operate them in airspace that's very heavily regulated, are you seeing the investment in the unmanned world coming from a groundswell of a lot of private investment, or is the lion's share going to be from the folks that were in the defense world in UASs?
Yeah, I think the big financial driver today in the UAS is moving to international sales, export sales, because Armed forces around the world recognize what UASs have done for the U.S., have moved it from a paradigm shift to where people say that'll never happen to where essentially no foot patrol should ever go out without a UAS overhead these days. And commanders who have used the modern robotic airplanes don't want to ever deploy without them again. And so other countries see that, and that's where I think that the short-term economic emphasis is all on export sales, because the domestic operations are so tied into opening up to the reform that has to take place with the FAA. I mean, I think that's, and people don't have a good feel for the certainty of the time frame on which that's going to happen, and that is a big, that holds back some of the investment, despite, as what you showed in your opening remarks, some really eye-popping projections that people have made. You know, having those projections come true is partly a technology function, partly an investment function, but an absolute prerequisite is regulatory reform. And I think investors feel they can't control that.
Each one of you touched on technology in the sector, and if you had to pick just the top two things that both industry and if we are able to get NASA or an aviation policy out of any one of the governments to focus on, what would be the most beneficial technologies that you would pick for each one of the sectors, Jack?
Well, you know, I think there's been a couple interesting comments made about technologies. You know, press mentioned the recognition of you can't just have technology for technology's sake. It's got to, you know, earn its way in the eyes of the customer. And then John talked about some of the technologies that are out there being developed that, if made applicable to the GA market, can really have some great opportunities in enhancing safety. And I think that's so it's around the economics of the airplane. I talked about diesel powers, diesel engine, all that. But I think if technology around really bending the curve over on GA safety can be made applicable at the right cost point and adopted so that it's easy to put on an airplane and use, those will be the real breakthroughs, because the payback will be there. People will see it. We'll get rid of some of the public perception issues we have with GA, with NTSB being on their top 10 most wanted list for safety, and other issues that become impediments of getting people into GA. So I think it's got to be in overall safety of the operation of the aircraft. And the technology's out there. I mean, look, right now, there's a significant amount of data that still shows the #1 cause in accidents in light GA is flying around in the pattern, installing and spinning. There's no excuse as to why we can't apply the proper technology, whether it be AOA indicators or other types of technologies that would never allow an airplane, aerodynamically and other things, to allow that to happen.
I always tell my friends that are in the unmanned world that, you know, if you can give the light aircraft guy a button that he can push, kind of like what Press was talking about, if the crew's incapacitated, get the airplane down autonomously to a place where they can wake up. If you can give the light guy a button they can push that, if they have an emergency, takes them toward the best airfield at the right glide speed while they manage the emergency, that would be a tremendous safety enhancer.
Second most is, you know, VFR and IFR. So if the individual doesn't have the skills or currency to fly an IFR, to be able to have an airplane that can get him to clear weather, that's going to have another big impact on safety.
Press, you touched on a lot of areas of advancement that Gulfstream has done, which has really carried the industry in a lot of areas, but then you also touched on supersonics. What would be the technology priorities for business aviation in the jet world?
Well, just as Jack mentioned, anything that improves upon the safety aspects has high priority. That's why we've spent a lot on vision systems. That's why I think in the end the real-time connectivity between airplane and ground will weigh into that as well. So that's one aspect of it, is always safety related, but the supersonic is another one, and NASA does have that as a priority in their aeronautics program to see what can be done to resolve the sonic boom issue and admit supersonic flight over land. It's clear from our customers that they want speed. They will pay dearly for speed capability, and the question is regular, when you're going to be able to do supersonic. And so safety and then supersonic capability is where we would have a high priority on.
Mike, you know, it's interesting to watch both Sikorsky and Eurocopter have very fast rotorcraft in their test phases, and then of course we have the Osprey out there. You know, is it a helicopter? Is it a turboprop? What is it? What kind of technologies do we need to see developed in rotorcraft or nurtured?
Well, it's interesting you bring up speed, because I wasn't going to mention that. So I think that compound helicopters have been demonstrated for over 50 years, and from a technology perspective, you know, they work. They have tremendous advantages, but rotorcraft are very cost constrained, so, you know, they're very expensive, and so adding additional things on them, additional propulsors, you know, add cost and weight and complexity. So I'd very much like to see compound helicopters be fielded, but in the you know, the 50 years or so of I think it's something like 3 dozen different compound helicopters that have been built and flown, none of them have ever gone into production. But I was actually going to respond as far as more of a regulatory perspective, and that is with fly-by-wire. So as I mentioned, there are no civil fly-by-wire rotorcraft that are certified, and so Bell and now Augusta-Westland have the civil tilt rotor, the 609, and that has been in development since 1996, and it's been flying since I think, I don't know, 2001 or so. And one of the big issues is how you certify a fly-by-wire rotorcraft, and now Bell announced their 525 Relentless, their big fly-by-wire helicopter, and it looks like that'll be the first civil fly-by-wire helicopter, and they believe their experience with the 609 gives them the knowledge and understanding of how to navigate through that certification process, but never been done before. So I think from a regulatory perspective, that's, you know, fly-by-wire is TRL-7. It's been demonstrated for 30 years, 20 years. It's been flying operation on the V-22 and the NH-90 helicopter, but it's and being developed for a couple additional military helicopters that haven't been fielded yet. But it's ready, and there it just needs to be, you know, fully developed or fully put into the marketplace. It needs to be, and the customers need to buy it and see the tremendous advantages that it has.
John, you touched on, you know, that export market for unmanned aerial systems growing perhaps more rapidly than in the U.S. because of some of the regulatory hurdles to getting them into the airspace. Is sense and avoid the biggest technology issue that we have to have out there? Do we have to provide a way that the unmanned system can avoid the pilot that cannot see a lot of these machines just because of the small size?
Ooh, don't get me started on that. I think sense and avoid is the biggest red herring in the whole business, and it goes to, again, fundamental issues of safety here, because the reason that commercial aviation is safe is it's not that the pilots sit up in the front and they look out the window and they see other airplanes and they avoid them. It's that there's a system that monitors everybody, and the air traffic controllers provide separation to that. And in the post 9/11 world, I don't understand how you can still fly in the United States airspace without self-identification. We have the technology to do it. We need to get to where ADS-B is mandatory for everything that flies in every category of airspace. And once you do that, then you can use that to do automatic separation of things that fly, and not just unmanned airplanes, but parachutists, gliders, weather balloons, high towers, all the other stuff that's in the airspace today that doesn't do its own see and avoid, and that people just don't worry about it. We've just gotten used to that, the existence of that, you know, low level of risk, and we accept it. We shouldn't accept it. That's a technology. We should fix that. The argument against it has been economic, But with ADS-B now well under $1,000 and headed down to, with a mandatory thing, you could get it down to a couple $100. An iPhone has every piece of technology, radio, GPS, and processor that you need to do the ADS-B mission. We should require everybody to have ADS-B, and then we can have systems built on that.
I would love to have you on a panel with AOPA. That's really interesting.
Exactly.
So
Keep them out of the helicopter airspace.
we
No, you've
touched.
got to integrate them right in. The small stuff's going to be right in with the helicopters, and that's one of the things we're going to talk about this afternoon, because my big fear is, my big question is, can we evolve sensible regulations without a catastrophic accident? Because the way I think it's kind of sad statement, but much of the progress in air traffic control and air safety in this country has come out of the results of accidents that we go, you know, that's just inexcusable. And then we finally act, even though most people knew long before the accident that this wasn't safe, and we just in a democracy have trouble agreeing what to do, right? And then only after a catastrophic accident. And I'm really worried about it, Mike. I mean, we're going to talk about that, but a small UAS, probably done by the do-it-yourself community, hitting a helicopter is going to be bad for everybody, and there's no excuse for us as professionals to let that happen. And yet, there's a lot of stuff that's pretty scary going on in there because we haven't moved forward with a regulatory regime that is really leans forward and accepts that helicopters are going to be interacting with small UASs. Let's do it before we have accidents.
I've got another one, and I'll circle back to that if we don't have questions from the audience, but I want to give some time for people to ask questions. Anybody that would like to? Anybody? Okay, the next one I'm going to ask gets right into that regulatory regime. Jack, you had tremendous experience, and you were a champion, and still are, on being able to get the FAA and the other regulators around the planet to look at capability that companies have to be able to produce product. I thought it was very poignant. I had Joe Brown, the head of Heart Soul, up with a congressman not too long ago, and he said, we've been producing props for 100 years, over 2,000 different types of props, produce them for the Wright brothers, and the FAA is still in our chili trying to tell us how to make a prop when they don't have a single expert that knows how to do it. When we look at the Part 23 revitalization and the Small Aircraft Revitalization Act that we've got going in Congress that EAA and GAMA and AOPA have been working on, why is that so needed?
There's, for a variety of reasons, and most of them are the ability for companies to be able to say it's worth making the investment to continue to produce new airplanes. The CJ2, which was certified back in, I guess it was early 2000, same airplane, I mean a derivative airplane of that, the CJ4, the amount of FAA required documentation and paperwork from a certification standpoint was 3 times what it was on the CJ2. Yet we also had a company that were supposed to have had complete delegation capability. So inherent in the companies is the ability at a much higher level of skill sets to be able to do this certification work. And it ends up creating a cost structure that, and as Press mentioned earlier, also is time of these programs that gets to be economically prohibitive from the payback. So I go out and study the market. There's so many, this product with this capability is a $6 million is what kind of the price point needs to be. I understand what my cost is, but that upfront development cost and money that is spent, if it continues to drag on and on and on, all of a sudden now it's no longer viable because the price point can't, it's not a price point that you can just continue to escalate because you spent more upfront because the market's not there. You can get me going on and on about it, but the issue really is efficiency of the certification process, where the knowledge base for the best technical decisions can be made, and an understanding of that, a handshake between manufacturers and engineers, manufacturers and the FAA as to where should those decisions be made. And I'll always argue, having run a publicly traded company, that the biggest liability and risk is not with the FAA and their insight into interpreting regulatory rules. It's around the company who is going to end up eventually getting sued. So you'll always see a company's technical department err to making sure that it is not only going to meet, you got to meet the standard, that's one thing, but am I going to uphold the value of my brand, my company, my longevity, which drives you to a different technical standard. So it gets down to economics, but if we don't, and again, especially in the lower end of GA, if we don't get to changing how we do business from a certification, you're going to see the international markets just take that from us. And I think, going back to your earlier Cirrus question, that's Cirrus being with the Chinese, I think that's something we should be very, very, very concerned about, that expertise in technology is moving to places that we rightfully have established and owned and developed here in this country, and is a part of our whole premise of what is behind our overall U.S. economy. And it's just going away, and we're not looking at all the pieces that need to change for it to continue to be established here. Certification being number one, and it's so easy to fix.
Press, in the business jet world, to tag on to what Jack was just talking about, we have two great companies, actually in the commercial world. We've got Boeing and Gulfstream that have been really picked out to be the vanguards of delegation. And we have moved to this process, ODA, eventually, hopefully moving to a process called CDO, Certified Design Organization. But there's bumps along the way, and still, for any of us to get product to market, we have to go through the regulator. And as you look at the jet world, how do you see, are we making headway with the regulators as far as allowing us, when you employ all those tremendous engineers down at Gulfstream, to be able to let them do their job and get product to market efficiently?
I think the effectiveness of the delegated organization, the ODA, has been less than we expected, let's put it that way. The FAA at the top clearly supports it. They know what the advantage is. They know what the advantage is for the manufacturer. They know what the advantage is for the FAA, but the implementation of it throughout the FAA organization has been a challenge for them. So we have implemented an ODA, but I would say it's probably less effective than we had hoped. It is a cost burden on the manufacturer, and you would expect some efficiency, more efficiency to come from it than we have seen so far. And so we continue to push on that. The point I made in my last chart in terms of getting the product to market, that's one of the things that really represents a problem is the burden of the regulation. I'll point to a couple examples of that. The current certification by the FAA still requires us to do a vast majority of the flight test work, fly the test points, document it, report it to the FAA. The FAA reviews the report and then says, okay, now it's time for me to witness it, and we go do it again. Other countries don't do it that way. Other countries allow credit for the first set of data if the configuration is correct and the data shows compliance with the regulation. So there's an automatic doubling of time or near doubling of time in flight test certification activity simply by the requirement that we've got to do it twice, once for us and once for the FAA. The second thing that's coming, which is it can be pretty scary, is that the standard for CO2 that's coming is going to add a new certification burden for everybody from Boeing and Airbus on down that says we will now certify cruise fuel efficiency. That's not something that's done today. That's not a certification requirement until the CO2 standard comes into place. Once the CO2 standard, which is nothing more than fuel burn, once that comes into place, you're going to have to certify your cruise performance to the FAA, and that will require you as part of your CERT program to demonstrate performance by some means of fuel efficiency, and you're going to do it first for yourself, and then you're going to do it for the FAA. And it's an added step that won't be insignificant. And so what we see is the ODA not as effective as it could be, some built-in unbelievable inefficiency for doing everything twice, and the burden on the horizon is going to be worse as a result of the effort coming for a CO2 standard, which in my way of looking at it, we've supported the development of standard to make sure that business aviation didn't get the shaft on the development of the standard. But at the same time, you have to question, why are we doing that? Because there isn't a manufacturer of aircraft in the world that doesn't try to minimize fuel burn, i.e. minimize CO2. So it is automatic. It is a default function of an airplane designed to minimize CO2, but we're going to have to now comply with the standard and create work to do that. So you pushed one of my hot buttons on that.
Mike, when we go to Rotorcraft, we have a Rotorcraft directorate that has been resistive to allow glass panel technology into the civil machines. And, you know, in Part 23 for fixed wing, 10 to the minus sixth is good enough. And when you look at a round steam gauge that is in a lot of these Rotorcraft, at a 10 to the minus third reliability, we've got a couple of our companies that are at 10 to the minus seventh, but yet the attitude in the FAA is that you have to have a backup to that 10 to the minus 7 device, even though it's thousands of times more reliable than the round gauge. And so we have this thing in the Rotorcraft world, and the Rotorcraft directorate then sends out an edict that the ACOs don't listen to, and that how big a regulatory impediment do we find this FAA certification regime in the Rotorcraft world?
That's actually not an area of expertise for me, so I can't really comment on that in depth. I will say that, you know, some of the new systems Garmin has and other companies have, they are being put into Rotorcraft. I know some of the both new models and even like the R66 are getting glass cockpits. So again, it's not a real area of expertise for me, but my understanding is they're getting through it, I guess.
One of the mindsets that we have to deal with some of the people in the Rotorcraft regulatory world is that we'll sit there and we'll try to proceed, and someone says, well, if we give them glass cockpit technology, then they'll fly into the weather, and they're supposed to be a VFR helicopter. And as aviators, we kind of look at it and go, yeah, but if you flying at night, sometimes you end up hitting the weather, and wouldn't you like a system that's reliable and actually works and can keep you safe? So it's something that's very frustrating that we deal with, and I think we had a question. Right.
Thank you, Pete. So everybody can hear me. I want to follow up sort of on what you just asked Mike, only not so much on maybe the use of a specific technology. Mike, I thought your charts were fascinating. I'd love to get a copy of them.
Absolutely.
In terms of sales, in terms of market, based on dollar size rather than sales, in terms of what the future trends are, and in terms of like the relative sort of investment in R&D in Europe versus the U.S. I wonder, from your perspective, the U.S. market having been relatively lucrative in the defense sector, if that hasn't in a way hindered this country's or been a deterrent to U.S. R&D investment that will now benefit the civilian market.
No, I think that's a really great perspective, and I agree. I think it has been. You know, there's well, for instance, 609 tilt rotor. Bell basically kind of put it on the back burner for 5 or 10 years because they had a lot of military customers that weren't happy with their deliveries. You know, the Marine Corps for the H-1 and H-1, UH-1, and the V-22. So I think it absolutely has been an impediment, unfortunately. And the military basically trained the U.S. industry to focus on upgrades and remanufacturers and you know, incremental improvements. And you know, as I said, there hasn't been a new helicopter fielded since, you know, there hasn't been a new helicopter successfully designed and fielded since the end of the Vietnam designs. So it's a real issue. I think, you know, NASA should invest more in rotorcraft. I think, you know, $100 million a year would be good, maybe a couple $100 million. I think it could really do some great things. But as I mentioned, in like some of the ideas around innovation, like spurring, electric STOL or VTOL vehicles, I think would be something really, something that NASA could, could partner with, maybe with like CAFE or AHS, and have some real breakthroughs in that. And then a final comment is traditionally, the last 20, well, I guess I'll say the 70s and 80s and maybe a little bit in the 90s, because the government, because DoD was investing so much in rotorcraft technology, there was a lot of fallout in civil technologies. And since that went away with putting all the money into Comanche, and then Comanche didn't actually get into a product, so since the 1990s, there hasn't really been much general, broader S&T development in rotorcraft. Now you see that the companies are investing money in a lot of technologies that they're aiming for the civil market, but may have some payoffs for military. So you see X2, X cubed, the Sikorsky H90 or S90 is now being militarized, and the Bell 525, is going to be, 525 is going to be the most advanced helicopter in the world, and it's, Bell's developing it. So I very much agree with your perspective and appreciate that.
John, I'm going to circle back with you for the last word and go back to the certification issue. When you got large companies out there employing thousands of people that are fighting for getting certification engineers to actually work on their project because of the diminishing number of engineers that the FAA has, and especially those that have expertise, how do we crack the nut with the number of UASs that are going to come into the system that are, quote, being required to be certified? And especially when you look at the difference, if a small operator comes in, he's got 2 or 3 employees, and yet that will soak up FAA resources versus a company that's employing thousands. How do we deal with that?
Well, I think there's sort of 2 pieces to that. One is that a lot of the statistical numbers of companies and airplanes are in the small section, and the FAA has a notice of proposed rulemaking that they haven't released, but if it follows the ARC that put it together, or that advised the FAA on putting it together, there's a compromise. The FAA doesn't have the time and the resources to certify every little 10-pound airplane, but certification standards for a little 10-pound airplane probably should be different than for a Gulfstream 650. And so I think there's going to be some evolution in the rulemaking. Second is the kind of stuff that Tom is doing at NASA, that a lot of the stuff we're talking about in really certifying these things, nobody really knows how to certify yet. I mean, these are things where as you put more and more automation into the system, and how you certify a non-determinate system is a fundamentally different question than how you proof load a wing and prove that it meets its ultimate load. And I don't think any of us know how to do that. And that is why programs like NASA's UAS and the NAS is so important, because they're out there trying to grapple with some of these issues about how does one reasonably certify a system that has a lot of automation in it, and what is a sensible rulemaking set of rules for some of the key things. And again, that's another area where the UAVs will be kind of the pathfinders. How do you certify a fully capable auto-land system that lands the airplane by itself every single time? It's, Tom's working on that. Tom has people working on that kind of project. That's exactly what we as an industry need NASA to focus on. And then the last thing is you will see it get introduced incrementally. Press was talking about a system that brings the plane down to 15,000 feet. Okay, why 15,000 feet? Why not 0? Why not bring it all the way in to landing on the runway? That can be done. Global Hawk does it every single flight. There's no way to take a Global Hawk over a stick and rudder and guide it in. The systems have to work every time. We'll get there. The way it's coming into manned aviation today is exactly as Press said, as an emergency system. That's in some of the, Cirrus has the parachute. Well, now there's, digital autopilot, digital parachutes that people like Rockwell are developing, and they'll come in first as an emergency system, largely because of the certification issues. The certification, how to certify a standby emergency system, people can get their heads around that a little bit easier than a primary system that you're totally dependent on.
Well, thank you very much. And you can tell we've got a lot to talk about in general aviation. It is an exciting sector of the aerospace industry here in the U.S. And I very much appreciate all the panelists being with us today, and thank you for your attendance.